Good morning, ladies and gentlemen. Thank you all for joining us today for today's webinar. My name is Christopher Brent, and I'm the Membership and Meetings Manager with UTC. I would like to welcome you to today's webinar, sponsored by Netcom Americas. And before I hand it off to Cristiano and Eduardo, I would like to go over a few housekeeping notes before we get started. Just so you all know, today's webinar is being recorded and will be available for on-demand replay for all of our attendees. And that replay will be housed in UTC Networks, where we will create a community specifically for this webinar. In that community, we will have the replay recording, as well as your PDH form for any continuing educational credits that you would like to receive for attending today's session. And lastly, if you would like to ask any questions, please feel free to do so during the presentation. But just please keep in mind that we will hold off on answering any questions until the completion of today's presentation. And to submit those questions, you would do so using the questions section of your GoToWebinar control panel, and we will answer those in the order in which they are received. So without further ado, I'll hand it off to Cristiano and Eduardo, and thank you all for joining us today.
Hello, everybody. Glad to be here with you today, and I hope that we'll have a good hour together talking about network resources, network operations, and digital transformation. Actually, in the title of our conference, Towards Digital Transformation, Taking Control of the Network, we mentioned digital transformation, but this presentation takes another point of view. We are looking at digital transformation from a network operations point of view. Digital transformation does not happen without the participation of the network. The networks must be in place, must be reliable, secure, and flexible, always available in order that digital transformation happens. Okay, so we are not dealing with digital transformation from the ITC point of view or from the business point of view. We're talking about what we must do to properly operate the network in this environment. My name is Cristiano Ferraz. I am the Chief Technology Officer of Netcom Americas. And Netcom, just a few words about the company, is an engineering and consulting company. We do master plans for telecommunications for companies in the telco business and for utilities as well. We do telecom projects. Actually, in the past 25 years, we have done hundreds of telecom projects, and we do our share of technical training as well. Besides doing engineering and consulting master plans and projects, we also do systems integration to help operate the telecom networks belonging to utilities and telcos. We have our own platform, which is called Netcom Platform, our own division that writes code called NetCode, and we have a complex but simple Connect Master inventory system. With this system, we can control the network from the physical layer to the logical layers, to the higher logical layers. So we do some software development, especially for integration of proprietary OSSs into BSSs and with each other and with a platform containing this knowledge of the network. Besides those activities, we also do some owners engineering, which is accompanying projects and making sure that everything runs according to schedule and as expected. We do project management. In project management, we do installation and commissioning ourselves, and if necessary, we also do turnkey projects for telecommunication networks for utilities and telcos. Okay, talking a little bit about digital transformation, let's go quickly over this timeline. And up until 2005, approximately, there was no talk of digital transformation, but information technology was already growing at a very fast and steady pace. As to operations themselves, telecom and information technology were under different teams in different departments. This was because telecom was focused on providing telecom resources to both for both voice communications, other types of communications, operational communications, but also to information technology interconnection, right? But starting in 2000, the main user of telecoms became information technology. So it was decided in many companies that the two groups should merge, telecoms groups and information technology groups. Since information technology was becoming the main customer, it was only logical that telecom should talk more closely to information technology. This is because formerly, until this time, IT was in charge also of local area networks and routers and networking equipment for long distance interconnection. What it took from telecom up to then was only the means of communication. However, operating routers, operating switches, local area networks was all under IT. What began with the new millennium is that communications became more integrated with information technology, and it was necessary to merge the operations under one division of the company of the enterprise. This only grew more intense over the next few years. Approximately from 2002 to more 2005, the concept of clouding computing and data centers came into play. This means that computer or processing resources which had been in silos where computers were put together to run the company's software started to be placed into data centers for economy, for ease of operation, and to share infrastructure resources such as power structures, such as climatization. Everything came together. And also because having data centers made it possible to use virtual machines, and virtual machines were easy to update, to make grow, to accompany the growth in information technology. So cloud computing became a reality in the first decade of this millennium. And because everything migrated to the cloud over the following years, there was a very strong need for better communications. Communications had to provide more bandwidth, traffic engineering, that means that delays should be kept at a minimum, availability should be 4 nines or something close to that, and the resources had to be operated and provisioned very quickly. All this led to a very steady growth in differentiation in the operation of the telecoms network. So the main customer placed its own requirements, and the network had to respond to that. But migrating to the cloud occurred primarily in the beginning with private clouds, with the appearance of private clouds. That is, large companies started to having their own data centers, putting their processing resources, their applications, their softwares, everything in those data centers in the cloud, somewhere in the private cloud. But later, other companies start offering this infrastructure at an even lower cost and more efficiency. So it's natural also that those private clouds evolved to public clouds. This also places a little bit more stress on network interconnection because we started connecting outside the company's own network and network resources and started using public resources to access the data centers. Okay. Because this was happening also soon, there was a need to monitor outside to monitor and diagnose failures outside the company itself. And this is when the concept of NPMD appeared, Network Performance monitoring, and diagnostics. Not everything in telecom was under the control of one OSS only, or even one room where the different OSSs were available. This concept, NPND, started then as a concept and then became more and more of a reality as time went by. Mostly, WAN control and telecommunications control were operated from separate OSSs, operation support systems, and they did not talk to each other. So it was necessary sometimes that, and also because some of the telecom resources were being taken from other companies, many times what the view that was allowed customers were allowed to see was not a complete view of the telecoms network. So sometimes NPNG required that probes were put in the network to monitor the performance of applications, traffic performance, the performance of the network, and end users also, what was coming and going from one place to the other, so that this monitoring would make available to the operations teams information necessary to ascertain if the work, if the worth of the network was good. That is, if all those network elements and network resources were working in an orchestrated way to provide good end user experience. That is the experience. That's the last acronym in under 2013. So EUE is what we call end user experience. The whole goal of operations was to provide better end use experience. And because the resources were under different operating systems and different views, it was necessary to integrate those views. And the information, the volume of information was too big to keep network control under one under manual control. So more and more over the last decade, we saw more and more machine learning techniques, artificial intelligence techniques in order to parse and process all the information that was coming from the distributed management information bases in the network and from the sensors, from the probes that were in the network, and analyze what was going on. This led to a change in the operation, in the way networks and IT were operated. And a new concern also came into play, which is called SecOps, security operations, because more and more the networks were, and the resources, the IT resources were placed outside the realm of the company itself. So the approach to security before that was to have everything inside one perimeter, a trust perimeter inside the company, and only offer some phase for outside access. But as network resources migrated to the cloud and access had to go over networks that were not really under the control of the operations teams of the company, there was a lot more concern with security, information security as well. So it was decided that the groups that operated the network were split into three main groups: development operations, which decides what IT is going to do, that is the planning for IT resources, applications, everything that has to do with information technology would be under this planning and engineering and operating group. The network operation was under another group, taking care of not only telecom, but also one wide area network. And finally, the security operations groups worried about security and made sure that everything was protected in there. At the same time, the pace of change went so fast that it was necessary to have more agile networks and more agile development and security operations as well. This is when concepts such as software-defined network and SD-WAN appeared. software-defined network made it possible from one point to provision service from one end and let the network do the job of connecting its parts to get service end to end quickly and surely provisioned with the proper quality of service to meet the requirements of this new IT, of digital transformation. And also another concept appeared, which is the virtualization of network functions, NFV, which meant that a network equipment that was one block at the beginning of the decade now moved to a generic software for doing the switching parts, the data plane in the network, but the control element of firewalls, routers, switches could reside in the data center on virtual machines elsewhere. So this is what NFV is called. This also made upgrading, adapting, reconfiguring, everything became easier when this moved to the cloud. And finally, there came the pandemics in 2020. And concepts that were only occasional up to then, like working from home and customer interaction with the company, became the rule. So no more an enclosed workforce, but the workforce began to work at home, and many times they had to do it over the internet, which is inherently not a secure network. And then our trust perimeter practically contracted to very few interactions. Most of the traffic came from outside. And because the network is not secure, security must consider all the communication in the network not to be trusted. So that is what happens today. We have zero trust network. We work security from the point of view of a zero trust network. Not only is the network not secure, but quality of service in an environment, the internet, which is not designed to provide reliability and availability, all the time availability and security, has also to change the paradigms of operation. So zero trust networking means that we have to deal with network resources which are not to be trusted. So a new security layer has to cover that zero trust networking that there is. So we have to provide alternative solutions for security, end-to-end security, a new layer on top of this zero trust network. And this is where we are now. So for 25 years, networks and network operations have been changing rapidly to keep pace with digital transformation. So this is where we are. When I talk about digital transformations, aside from the network, the goals of digital transformation are improving end user experience, increase operation efficiency, so we cannot wait a long time until something starts happening. When needed, it must enter into service immediately. We have to increase profitability of our main business, and if possible, our network resources need also to bring some profits into the picture, or at least decrease their costs. We have to bring service to the market faster, improve the agility of our company, grow revenue, enable digital engagement, and specifically in utilities, we have to act very quickly and very efficiently in order not to lose any revenue. And how do we achieve those goals? Well, the first worry that people in IT and DevOps have is automating operational processes and procedures, doing as little as possible by hand. Keeping in mind that in utilities, telecommunication networks are mission critical, because not only the business and administrative processes run on those networks, but also operation runs on those networks. So the networks need to attend to the needs of operation and corporate communications. So to do that, we have to update and automate the operational processes and procedures, upgrade legacy IT systems that had been unchanged over the last 20 years are changing very quickly now. we have to have end user engagement. End user, by end user, we mean not only the public, but also the workforce that is many times outside the company. And finally, we have to modernize the operation itself. The operation support systems and business support systems are changing also at a very rapid pace, and they need to be integrated. That is, if we sell or require a new connection, then the BSS must inform the OSS, the operation support system, and this must be available as soon as possible and with the correct quality of service. In this webinar, we're not going to focus on digital transformation goals, but networks and network operations, because it is such an important part of this picture. As we mentioned before, the three main operation groups that are working in unison are development operations, network operations, and security operations. And in the last few years, there have other concepts been appearing. If we have some time, some more time, and at another time, we can talk about those other groups. DevSec, which is a joint group of development of new solutions and security embedded in those solutions. Systems operations, data operations, artificial intelligence operations, those are new groups that are coming up. But we'll focus, as we said, on network operations, whose jobs are creating an agile and programmable network. So we do not program by hand, we do not install by hand anymore. So there is a platform that must very rapidly and in a programmable way allocate network resources for the necessary communications within this picture. And we need to use integrated and programmable methods for fast, reliable, and secure service delivery with the right quality of service, which means low delays, which means availability, 4 nines availability, and which means no interruption. So always diversity of means, a diversity of connections so that the service will go on even if something fails underneath. And the other thing is viewing and controlling all network layers and connections, which includes the physical layer. When I talk about SDN, SD1, we usually are talking about the logical connections on top of the network, but we do not often include in the picture the physical layer. By physical layer, we mean ducts, we mean fiber optic cables, we mean fiber, optical fiber, we mean also wireless communications, point-to-point or point-to-multipoint communications over radio waves. So all that must be included in the picture as well, because we need to see how one network layer is connected and affects all other layers, security and quality of service and user experience. The thing is, OSSs must share one consolidated network information base. So it is necessary that the network information base covers every layer in the network and is aware of what's happening at the physical level and what services cross any given point in the network. When, for example, there is a fiber break or a radio link fails, what services, what locations, what end users are going to be affected? And if there is a complaint from a user, we have to know which connections, from the logical connections, from the SONET connections, from the carrier Ethernet connection, and PLS VPNs, down to the optical fibers that transport the information. Okay, we have to know all that in the operations. So there are new concerns about networks, which are the scope and reach of applications, new demands on traffic, new demands on resilience. Resilience means that if one means of communication fails, then another one must be available to restore communication in a few milliseconds. And this is done through path and resource diversity. We're not going to talk about that right now, but even if we have connections over the internet, they must be over diverse internet connections, so that if one connection fails, the other one takes over. Cybersecurity must be built in. For example, again, talking over the internet, cybersecurity may extend a layer over the internet connections and send part of the information on one connection, another part on another connection, another part on a third connection, and then the whole information must be assembled at the other side. And if you lose one of those connections, the other two will support the communication. And if somebody eavesdrop one of those connections, you will not be able to assemble the information that was sent over those diverse paths. So this is what we're talking about here. And we have to include that in our picture of the network. And then service availability and fast recovery from failures, especially for mission critical applications. Like operations, system operations, we need fast recoveries in the milliseconds range. Quick service provisioning, because the network is changing so quickly, provisioning must be fast. Nobody's waiting 2 months for an engineering project to be made in order that a new location is connected. And the configuration, more bandwidth for a sudden growth in need. This should also be quick. And finally, fault location, diagnostics, and anomalous behavior analysis. Anomalous behavior serves two purposes. One of the purposes is detecting any anomaly in traffic or end user behavior so that a potential threat is identified, but also trends in traffic, trends in user behavior should also be used, should also be known and analyzed so that a prognosis of what's happening helps our operation to do a future-proof configuration. Know what's happening now and prepare for the future. Visibility and management of third-party services and resources over which we have no control, and use of zero-trust networks. This means that ITC operations needs to evolve together with those needs. Taking control of the network then needs restructuring the operation into those groups that we mentioned. It also means having to include the physical layer into the managed network environment. This is part of that taking control of the network, and adding a new security layer everywhere and assuming a zero trust network environment and taking control of a diverse network. Different players, different network technologies, different operation support systems, and different providers, network service providers also, different cloud service providers. All that means that we are working in a very diverse network. In utilities especially, because we have to plan our network for the worst case, there is usually some capacity that can be shared with other businesses, especially now when we see in the Internet of Things coming up and 5G communications coming up. Many of the points of presence that we have in our network become of great value to the outside community. And resource sharing is a business that has already started in many of the utilities we are working with. And we are helping our clients to facilitate resource sharing and control that business as well. And we need to automate operational process, focusing on ease of configuration, of use, resilience, security, all that we have mentioned before. And the main hurdles are the integration of different OSSs and including the visibility of the physical layer. So the goals of the network operation groups becomes a very fast and reliable service configuration, greater awareness of network resource usage and traffic, especially the physical layer is usually only viewable in, for example, spreadsheets. If we have automation in seeing the usage of our network resources, we can quickly provide network physical resources for new communication. Okay? Network management over diverse network environments, I've mentioned that yet. And finally, consolidating and integrating the information that comes from the different OSSs and from the network inventory into an integrated, a consolidated, detailed view of the network. The challenges are that SDN and SD1 rely on a programmable networks resources, not only on logical layers, but also on lower layers. And this view now includes only logical connections. The physical layer must be part of the picture. Otherwise, we say we need more bandwidth from this place to this place, and we have to check if a physical connection is available between those places. And OSSs are often not integrated. They are operated separately on several screens, and they do not share information with each other. So the main challenge, and that is one of our main focuses as a company, is OSS integration from physical to logical connections and provide a common visibility of all the different network layers. And this correlated vision also allows us in operation to ascertain end user experience. So we are not relying on what the user is saying, but from the information that we obtain about the connections and their degree of usage, we can ascertain what the end user is experiencing now. And thus, we can manage the network according to this abstract end user development. Our role as a company, Netcon America's role as a company, is what I told you when we were reviewing the first slide. And we've done that for 25 years. We have provided telecommunications engineering, integration solutions for OSSs and consulting to utilities all over the Americas and telecom operators as well. And one of the advantages of being an engineering company is that we are vendor and technology neutral. So when our customers contact us, we can offer a very neutral point of view as regards the technologies that better serve the client's purpose and which vendors provides that technology. So we are able to write not only the planning, but also technical specifications and even basic projects of what works well with something else, and how this all contributes for a very economic and perfectly fit solution to the customer's needs. Okay, and for that we have, as we said before, one division which is called NetCode that writes codes and programs interfaces between operation systems and network platform, where the whole information that comes about the network resides. Okay, we do software development for systems integration, and the Connect Master is our platform that we use as a primary information base for integrating the information of all physical and passive network resources and connections with higher network layers. I've tried to make this as short as possible. It's a lot of information for such a short time. I hope I have not made you too tired with all that. But let's proceed to the practical part, the study case, to show how this vision that we have works in practice. So please stay with our Chief Operations Officer, Ed Landgraf, and he'll show you the complete information and how it appears into a common operational information base, and thus he'll show you how to take control of the network. Thank you. If you have any questions, at the end, we'll leave a quarter of an hour to address your questions, and we'll be available at any time. There is our contact information for you consulting any of our experts here. Thank you very much. Landgraf, it's you.
All right, thank you, Cristiano. It's always great to learn from you. I'm Eduardo Landgraf. I'm the COO of our BSS business unit in Netcon. I'm not going to talk about my background because I think you have it in the invitation from the UTC. I just want to say thank you to the UTC organization for having us today and all the audience for participating in this webinar. Just want to confirm, Cristiano, can you see my screen with the Connect Master?
Yes, yes, I can see it.
Very good, thank you. All right, so Connect Master, it's our inventory management solution. It actually enables companies to take advantage of the digital transformation, and it's the software that enables you to consolidate all the different network layers into a single solution. So the Connect Master has like just 3 main panels. This is the Network Explorer panel. Then we have the Fast Access panel and the Navigation panel, where we can see our GIS integrated tool. So right now we can configure the Explorer according to the customer needs. So right here I have state of New York City. Then I can go down to the different location types. And when I get to my data center, I can navigate through the floors and check all internal conduits and shafts until I get to my telecom room. And when we get to a telecommunications room, we have all the physical components in that specific room, followed by the logical circuit, so we can have the logical layers integrated in Connect Master, plus the electrical network, so we can also have a view of how the power consumption is within that specific data center. So I can right-click a data center and show in current map. So that will locate the data center at the specific site, as well as I can right-click and open the detail. The detail will give me lots of information, which will be distributed over multiple tabs. So I can have a picture of my data center. I can check the power balance and power consumption, on how much I have in supply, consumers, and the balance here, and a complete view of my electrical network within that specific data center. Once I'm within the data center, I can also go to the Documents tab, which is where I can see specific documents about this. So for example, I can open my floor plan of the data center, and this gives me a complete view of how the racks are organized and like the physical visibility of the data center. So by selecting a specific rack, like the DWDM rack here, I can also locate the rack in my data center plan just by selecting the show in current drawing. So I have showing current map as well as showing current drawing, and that will locate the component or the rack within the data center. I can also navigate from the floor plan. If I double click on a specific rack, I can have a summary of information, and I can run, let's say, an impact analysis of what happens if I lose power for the rack, what circuits will be affected, and Connect Master will immediately tell you that for all the different network layers. Okay, as I drill down to a specific rack, I can right-click and open, let's say, I can go up to the ports here and see what specific services I have in a switch. I can open the switch detail, and I can control the physical configuration. I can see the picture. I can see what physical SFPs I have inserted in that specific device. And this is the physical configuration of your device. But I can also manage the logical configuration, which is why we have the second tab, Mux Usage. And I can see the services that I have on this specific switch, as well as who is my customer and what specific component we are connected in that specific customer. So from here, this is the service. I'm already on the layer 3, my layer 2 Ethernet and layer 3 IP. I can right-click the service itself and see what infrastructure elements are associated with that specific circuit. So I see the circuit coming all the way from the data center towards my customer side. So this is how Connect Master combines the physical network information with the logical layers. Okay. So we can also, for a specific rack, we can select the rack, right-click, and connect master interfaces with Microsoft Visio to produce network schematics. So the make drawing command will create a drawing in Microsoft Visio. So Visio is open within Connect Master, and at the same time, Connect Master starts to look at the database and search and see what is the latest configuration, because the drawings are produced always with the latest updated information in your database. So now Connect Master is reading the database, and it's going to be able to produce a rack elevation drawing for us. It will take just a few seconds more and should be ready. So, and because we use Visio, we can customize the stencils to show a realistic view of your racks, including all the specific ports. And then you can also see what ports are in use. What, like the red ports here, means that these are used ports with services. As you zoom in, you can see the active ports, you can see the SFPs that are there, but they are not used yet. And as you scroll down, you can see all the rack occupation produced by Connect Master. So from the Visio, you can also navigate. So if you double click a picture like a Visio shape, you can have a detailed view. And from here, it's pretty easy to open physical path in case you want to check physical connections for a specific patch panel, and you can do it from the Visio. So this is more related to physical inventory. So let me go now to Florida, where I have a good scenario to show you a logical and how these layers will interface with each other. So I have a data center here, and again, I have all my physical components followed by the logical circuits and the electrical networks. So like here I have a DWDM circuit. I can click on the DWDM and show in current map or showing cables on map. What are the cables associated to these specific services? And Connect Master will highlight the cable for us on the geo. So DWDM is the base layer, right? So I can open the detail for the logical circuit and see how the channels are being used. So I have, out of 8 channels, I have 6 free channels and 2 channels in use. And then this is actually a DWDM carrying an OTN circuit. And as I open the OTN section in the Explorer, I can also see the OTN layers, and I can see all the way from the ODU4 to ODU2, ODU1, ODU0s, and all these different capacitors are managed by Connect Master. So especially in utilities sector, we have a lot of SONET devices and SONET equipments. I know this is gradually phasing out with the adoption of MPLS based networks, but it's still it's a very largely used technology. So Connect Master also manages SONET and TDM technologies. I can open the OC3 circuit detail, and I can see here in the routing editor what is the actually multiplexer locations and cards that provide the circuit. I can go to logical assignment, and I can drill down to the DS1 level, where I can see how am I using the DS1 channels within a SONET section. I can also analyze the statistics, so that can be visualized in a statistical dashboard, which tells me all about the occupation of my, in this case, an OC3 155 megabits, if I'm not wrong. So and then you can see here how many DS1s you have and DS0s, and all the different upper levels between OC3 and the DS1. And this is the intelligence that Connect Master brings by intelligently managing these different types of networks. So I'm going to show you a TDM circuit, and Connect Master will produce you the fiber plan diagram, the physical diagram for a physical connection, but it also does the same for the logical layers. So when I have a DS1, the DS1 is carried over a SONET layer, and the SONET may be carried by a DWDM layer, which is then associated to a fiber. So this is what we can see in this combined view of Connect Master. I can see here the main path for my DS1 protection path. So I see all the cards, all the stations, the multiplexers involved, and I can go to the routing view tab, and from here I can draw a routing network diagram to see all the physical infrastructure. But just before that, here is where I can see what physical elements are associated with the logical circuit, and that can be represented in a routing network diagram as well. So this is like my OC3 circuit, and I can organize the specific drawing to show that's the protection path, that's the main path, and these are my three multiplexers, and I can also see the ports, the cards that are establishing this DS1 circuit. Okay, now just to close my portion, then we can go to the questions. I just want to show you that we also managed all the different technologies. We also manage the VPN, different services in MPLS, such as VOL, VPLS, and VPRN. So in here, I have a customer which can, I can see an LSP, which this is an LSP provided over an Ethernet network. And I can do the same. So the LSP will be transported over multiple Ethernet circuits, and I can draw the routing network, and this will show me all the lower layer that are providing this MPLS specific service, this LSP. So just to finish, I want to do a fault simulation here before we go to the question, so that you can see how this physical layer is all interconnected with the upper layers and the upper layer protocols. So when I right-click a cable, I can open the quick view, and in here I can run impact analysis. But just let me show you first here the OTDR function, which is also very important. So we can do this from, so this is my cable. I can see connections within the cable, right? And I can take specific, let's say a fiber, open the fiber detail, and this will give me the end-to-end view for the circuit. And this is just a point-to-point going from two data centers. But I can run a OTDR. So the total length is like 4,000 feet. I can say what happens if there is a failure at 2,456, and Connect Master should identify that on the map and showing me that there is a fiber break here, and I can immediately create the OTDR report for maintenance services. And this brings me the coordinates, the fiber involved, the closest reference point, and how we should do. And we can from here send an email to our technicians. And lastly, we run the impact and analyzer to see what is affected. So what services have I lost due to that fiber break? And when I analyze, Connect Master brings me all the different circuits that are involved, including all the network layers and protocols. So I can see here that cable break, it's affecting the DWDM layer, is affecting my SONET TDM layer, as well as my OTN layer and my VPLS services, VPN services as well. So this is Connect Master. It's a very efficient tool to allow companies to integrate and have this consolidated view of your physical and logical inventory. And we are going to be here always to help you to learn more about the software. And I hope you have enjoyed this little demonstration of Connect Master. So now I'm passing back to Christopher so we can go to the questions and answer session.
While I was watching your presentation, Ed, I was wondering, how is this whole world of information coming into the platform? So is
Yes.
it a lot of work, or do you import information from charts, spreadsheets, maps, or?
Yeah, that's a very good question. And normally that's the challenge when we are implementing a software like this. So Netcon has a team of expert professionals. We have migrated information from many different sources, including AutoCAD, MicroStation, Google Earth. Some companies, they have just a basic layout of their network in Google. So all this information, because we use the underlying technologies in ConnectMaster, allows us to import this information. Plus, ConnectMaster has templates that allows you to just enter the information and automatically load. And this is when we are talking about the physical inventory. But when we talk about the logical, ConnectMaster also has a module called DSE, which is Data Synchronization Engine. So the DSE connects to the NMS and gets all the information for the physical configuration, your chassis, your cards, your ports, and what logical circuits we have on that. And this is automatically synchronized into the database. So, and we will help you to achieve having your consolidated inventory in place.
So if a utility is selling services or network resources, they can do a quick consult to the database, and from this database, they can say, well, we can provide the service tomorrow. And then you issue, over the system, you issue a work order, and this is done, and the next day, your customer will have the service up and going.
Certainly, there is much more in ConnectMaster. Like we have an auto routing engine, so I can select 2 random locations, and ConnectMaster will tell me if I have circuits already connecting those 2 sites, if I have fibers, and if I don't have fibers, it will find the free fibers along the cable route, and will get you a work order for you to install that specific circuit. So it's a really very important tool to help companies to easily perform their daily activities.
Right.
So,
okay,
is there questions or?
Yeah, so thank you all. I don't see any questions in the chat at the moment. So in case if anyone does have any questions before we close up, once again, please feel free to submit those now. As I stated at the beginning of our webinar today, this is being recorded and will be available for on-demand replay for all of our attendees. And I know that both Eduardo and Cristiano had their contact information in the presentation, so that if you would like to reach out to them after today, you will be able to do so. Doesn't look like we have any questions. I would like to thank Netcon and specifically Cristiano and Eduardo for giving such an amazing presentation today. It was a pleasure working with the 2 of you. Do either one of you have any final words you would like to say before we close out today?
Cristiano, you first.
Yes, that was a lot to say in such a short time. I hope we have not overwhelmed you with this information. But if we have, you can always get in touch with us and we'll do it on a more extended period of time. And we can talk more deeply about your contexts, your particular contexts individually, okay? And that's what we do. And we take great pleasure in our work, and we'd certainly be willing to know more about you, about your problems, about your activities, and find out in which ways we could work together to make this a better world of communications. Thank you very much for being present at this presentation and for bearing with us for such a long time. Thank you.
Yeah, very good, Cristiano. Thank you so much for these great words. I just want to thank you all, the audience, for being here with us, for the chance of showing you our ConnectMaster software and talk about digital transformation. We will always be here to support you and provide more information as you need about the softwares and the services that Netcon provides. I also want to thank you, Christopher, for your time and spending this hour with us. And thank you very much again.
It does look like we had one question come in. So before we close up for today, the question asks, how long does it take to implement Connect Master in a typical installation?
Okay, yeah, that's a very good question. So I would say to install Connect Master, we have to have a workshop with the customer to first understand how the data model will look like. So we are going to define the structure of sites and how that's going to be translated into the Connect Master Explorer panel. We're going to talk about auto naming rules. So how do you want to, and this is a very important part of the implementation process, because normally you have your cables drawn in AutoCAD, but not necessarily they have a name. So we're going to have to agree on what naming conventions you will adopt for all your physical infrastructure and for your logical services. And that normally takes about 15 days after we start the project, right? Having the definitions for all the physical and logical layers. Connect Master is also modular. So depending on what modules you have, that may vary a little bit. There are customers using only for the physical inventory, but also other customers using with the logical modules also. So, and that's the configuration step. Then we go to the data migration. Data migration, depending on how the company has the information. So we're going to use Connect Master's CSV importers to load it. And that process can take around 2 months, depending on the data amount, depending on the network size. But I would say for customers that want to have a solution, what we call the greenfield solution, so that they can start documenting, it will take a month. For companies that want to do the data migration, it will take around 3 months to 6 months, and that is including migrating all the data into Connect Master's database with our support.
Yeah, of course, that all depends on the size of the network that you're mapping into the
Sure.
right? So you're talking about a large utility or a large company with 100 locations or 200 locations, right?
Yeah, and how well the data, yes, I would say that. And also that depends on how well the data is currently structured in electronic formats, right? So, and if there will be the need for any manual work to map from like papers into the and digitalize into Connect Master's database. And this is what Netcon can help you with.
Yes, and because the system is modular, it will serve, for example, a small utility. Well, the water department in a city as big as LA or as small as Love, Texas, with 400 inhabitants, and then it will take much less time if you're talking about a small location than if you're talking about a city with millions of inhabitants and a whole meshed network of ducts and cables, right? But let's take an example. So a mid-size example. You have done companies in Texas, in California.
Yeah,
so
I would say that would be between 3 to 6 months to have it implemented. And in some cases, we deliver first the physical network migrated into Connect Master. Then we start working on the logical layers. So it's actually a gradual approach, because users can be working in building and adjusting the physical layer while we work on migrating the logical layers into the system. So the time, depending on the company, the data silos, would be around 3 to 6 months, and it can be a little longer, but normally that's the time frame for the Connect Master deployment.
Great.
And after we deliver all that, Grafi, it's who operates the system?
So normally the engineers, the engineering team, operational team, we also have APIs that will allow the sales team to use the database and in order to be able to sell services over your network. So it's actually the source of truth that will provide information for CRMs to be used by sales teams, for network OSS systems to operate and locate failures and affected services. So it's used across multiple areas within a company, but mostly used by the engineering and in operational teams.
Thank you guys so much. And we are at 12 o'clock local time here in DC. So we'll go ahead and close up for today. So thank you once again, Eduardo and Cristiano. This is a great presentation. Thank you to NetCon for sponsoring today's webinar. And we hope that everyone enjoyed today's presentation, and we will see you all again in a future webinar here at UTC. So with that being said, thank you all and have a great rest of your afternoon.
Thank you all.
You.
You especially.
Thank you guys.
Thank you.
Bye-bye.